Hey folks, welcome to lecture 4.3, part 2. We've been talking about intermolecular forces of attraction in molecules and compounds, and now we're going to do a little practice exercise and work through some problems together. Okay, so we left off with this flow chart on how to determine the type of intermolecular forces of attraction that are present in a covalent compound. So with that in mind, let's take a look at practice exercise 4.14. There's a pair of molecules presented in each case, and we want to determine what type of intermolecular forces of attraction are present in each compound, and then circle the one that has the stronger forces of attraction. So go ahead and pause this and work through A, B, C, and D, and when you come back, we'll go over the answers. Okay, so welcome back. For A, we can look at first, remember, determine if it's a polar or non-polar molecule. And so on the left is ethane. You don't need to know that name. And but you can tell that it's a non-polar molecule, and so it has dispersion forces. And on the right is a polar molecule, but it does not have one of the three that we need for hydrogen bonding, so it is dipole-dipole forces. Now, to clear up, it does have hydrogens and it does have oxygens, and the oxygen has the partial negative, hydrogens have the partial positive. But in order to have hydrogen bonding, the oxygens have to actually be bonded to a hydrogen, and in this case, the hydrogens are bonded to carbon. So even though oxygens and hydrogens are present, it is not hydrogen bonding. We have dipole-dipole forces. Okay, B was HCl and HF. So these are both polar molecules, and HCl has dipole-dipole forces, but HF has hydrogen bonding forces because that bond dipole is so strong. So it is the stronger. Now F2 and HF. So F2 is nonpolar, right? Even though F has a very high electronegativity, if both atoms in a bond are the same thing, it is equal tug of war, and it is a nonpolar bond. So F2 would be a nonpolar molecule with dispersion forces. And once again, HF has hydrogen bonding forces. Next is CH2Cl2 and CCl4. And CH2Cl2 has stronger forces of attraction because it is a polar molecule. CCl4 is a non-polar molecule with just dispersion forces. All right, next, a couple of multiple choice questions. So the first one is pretty basic. Which force is the strongest? Dispersion forces, covalent bond forces, hydrogen bonding forces, or dipole-dipole forces? Pause and answer. Okay, welcome back. The answer is covalent bond forces, right? These are intramolecular forces. Now, as far as intermolecular forces, hydrogen bonding forces are stronger, but overall, the strongest force is still the covalent bond. On the flip side, which force is the weakest? Yes, indeed, dispersion forces are the weakest. Next question. Select the compound that forms the strongest intermolecular forces of attraction from these three compounds. So, not talking about bonds here, just intermolecular. So that would be H bonding is greater than dipole-dipole is greater than dispersion. And we look at polarity to determine this. Okay, so which one has, I guess we could look at, does any of them have hydrogen bonding? And if so, then that's the strongest. If not, then we'll move on to dipole-dipole. So F2, right, is, we've already seen this one, nonpolar, that's dispersion forces. That's weak. HCl is a polar molecule. It has dipole-dipole. And NH3 is polar, but it also has NH, right? It has the NH bond, so that's hydrogen bonding. So which one has the strongest? That would be NH3, and only NH3. It's in a category by itself. Okay, so we kind of already answered this one because we had a pretty thorough analysis of the last question, so we know now that the weakest of these would be what? F2. Yes. All right, putting it all together as promised. Here are some compounds or some molecular formulas. So we want to name the compound, draw the Lewis structure, determine the electron geometry and the molecular shape, estimate the bond angles, determine if it's polar or nonpolar, and determine the type of intermolecular forces of attraction. It's a lot of things that you know how to do now. So we've actually done, I can only give you so many examples before you start to repeat, because we've seen basically all of the possible shapes. So let's just start with the top though, CCl4. Our first task is to name the covalent compound. So here we use Greek prefixes, and so this would be what? Carbon tetrachloride. Next is to draw the Lewis structure. Next is electron geometry and molecular geometry. And in this case, they're both tetrahedral. So that twice. And then estimate the bond angles between carbon and chloride. 3 of them would be 109.5. Determine if it's polar or nonpolar. So this is nonpolar. So that means that the forces are dispersion. All right, next. I'm going through this quickly because I am going to assume that you take the time to pause it and answer for yourself and do the hard work for yourself. And here we'll just check. All right, CO2 is carbon dioxide. You've drawn this Lewis structure many times now. And it's a linear electron geometry and linear molecular geometry. The bond angle is 180 degrees. It is a non-polar molecule, even though it's a polar bond, and therefore we have dispersion forces of attraction. Next, NH3, which has a special name of ammonia, but we can still give it the technical name. The standard nomenclature would be nitrogen trihydride. Okay, and the Lewis structure. Again, we've drawn this one many times. Looks like so. The electron geometry is tetrahedral, but the molecular shape is not tetrahedral because of the lone pair. It's trigonal pyramidal. The bond angles would be approximately 109. This is a polar molecule, and it has hydrogen bonding intermolecular forces. Okay, then last one is CH2O. And we've only talked about naming binary covalent compounds. That means it has two atoms. And so we're not going to have a standard name for this one. So that's kind of an exception. It is called formaldehyde, which you may or may not know. It's okay if you don't. But we can still draw the Lewis structure. Again, we've done this one. And the electron geometry and the shape are both trigonal planar. The bond angle would be 120 degrees. It is in fact polar, and it has dipole-dipole intermolecular forces. Okay, so that actually wraps up chapter 4 for us. And so I encourage you to take a look at the back of the chapter. And on page 144 is a list of all of the core concepts of the whole chapter, separated by sections. Followed by that is a list of keywords in alphabetical order. And followed on page 146 are additional exercises. So after you've done the homework, after you've done the learning curve, if you want more practice, you can check out the additional exercises starting on page 146. And they are also separated out by section, so you can focus on whichever section you want to. Okay, that's it, folks. See you next time.